Hi, in this video, we'll be discussing algebra pertaining to exponential and logarithmic functions. The question goes, the loudness L decibels of a sound is given by L to be equals to a 10th Lg brackets I divided by I naught, where I refers to the sound intensity to be measured, and I naught is the minimum sound intensity that can be heard by a human. In part A, given that the loudness of a thunder is 120 decibels, find the ratio of the sound intensity of the thunder to the minimum sound intensity that can be heard by a human. And that's a 2 marks question. In part B, given that the minimum sound intensity that can be heard by a human occurs when L equals to 90 decibels and I equals to 10 to the power of negative 3. Find the loudness of a plane taking off if its intensity is 100. And that's a 3 marks question. Now, you might want to pause this video to give this question a try, and when you're ready, keep watching. Now let's take a look at this question first before we go into the solution. Now in this question, it's pretty complicated. Consider the fact that the equation is confusing. So now let's first highlight all the different algebraic, the unknowns first. So in this case, the loudness L. So L refers to the loudness. So by L in this case refers to the loudness in this case. So let me just highlight L in yellow like this. And I refers to the sound intensity that is to be measured. So this is yet another variable, I. So let me just highlight I in greens. I naught, alright, this is pronounced as I naught, is the minimum sound intensity that can be heard by a human. Now this doesn't change, this is in fact fixed. I consider this as a constant. Fixed. It's not a variable, it's fixed. So in this equation, we have L to be a variable, I to be another variable, and I naught in this case is a constant. In part A, given that the loudness of a thunder is 120 decibels, so the giveaway is that it says the loudness. So this one refers to the yellow color L. And 120 decibels, the units will tell us that this is the variable L. So we're going to replace the L to be 120 decibels, and we are supposed to find the ratio of the sound intensity of this thunder in green, which is I. And the minimum sound intensity that can be heard by the humans, in this case, minimum sound intensity is therefore the one in turquoise, which is in blue, which is the minimum sound intensity here. In part B, given that the minimum sound intensity, once again, is in blue, that can be heard by a human occurs when L equals 90 decibels. So L, in this case, they give us the L in this case. We're going to change it to yellow. I refers to 10 to the power of negative 3. We're going to change the I to the 10 to the power of negative 3. Find the loudness So by logness, in other words, you are supposed to find L when its intensity is 100. This one is green. So once you are able to distinguish all the different unknowns, before we start the solution, we might want to first revise or recap on the previous logarithmic formulas. So first thing first, we might want to revise on this. From logarithmic form to exponential form. How do we change from logarithmic form to exponential form? So if it's in the logarithmic form, you have x equals to log y to the base of a. So x equals to log y to the base of a. Now, if you want to change this from logarithmic form to an exponential form, we start with the base of a in this case. So we start with the base of a, we push the other side up, so therefore this will be a to the power of x equals to y. A to the power of x. So start with the base of a to the power of x. So a to the power of x equals to y. So this is the very first formula we'll need for this question later on. The second formula that we'll also need is the quotient law of logarithms. So by quotient law, it means to say that if I have a log x over y to the base of a. So if I have a log x over y to the base of a like this, x over y to the base of a, it can be split into two different logs of the same base, which is log x to the base of a minus away log y to the base of a in this case. So a single log can be split into the two logs like this of the same base. So inside divides becomes a minus like this. So that is the meaning of the quotient law of logarithms. Now with all this in mind, we can then start to solve this question. So first up, in part A, we are told that the loudness of a thunder is 120 decibels. So we will first need to sub this 120 decibels, sub L in this case, because we know that it's in yellow. So sub L to be equals to 120 into L equations. Alright, so sub L equals to 120 like this, which is the one in yellow, into the L equations. So into this L equations, so therefore we should be having 120 equals to 10 Lg, which is log to the base of 10, a natural log to the base of 10, brackets, I divided by I naught. Now, dividing by 10 throughout the entire equations, we should be having a 12 on the left equals to Lg, I divided by I naught. Like this. Now let's not forget that Lg is log to the base of 10. Now what we want to be doing is to change from log form to an index form. To change from log form to an index form, basically the idea is very simple. We start with the base of a like this. We start with the base of a, we push the other side up. So in this case, this is the base of 10, we push the other side out. In other words, we're going to have I divided by I naught equals to 10 to the power of 12. So now notice that this is the exact ratio that we need because they want us to find the I in this case, the ratio of I to I naught. So the ratio of the sound intensity to the minimum sound intensity. So the sound intensity of the thunder, the one that is to be measured, is in green like this. So I to I naught is actually 10 to the power of 12. So now let's put it in the statements like this. So therefore, ratio of sound intensity of the thunder to the minimum sound intensity that can be heard by a human is not only 10 to the power of 12, it's actually 10 to the power of 12 is to 1 because they want it in a ratio form. So this is the answer for part A. Now let us continue with part B. So in part B, we are supposed to find the minimum sound intensity first. Alright, because there is a constant. Let's not forget that the minimum sound intensity that can be heard by a human is a constant. It is not something that can change. It is a constant, it is fixed. So therefore, we have to sub L to be 90, at the same time sub I to be 10 to the power negative 3 into this equation to solve for I naught. So once you are able to solve for I naught like this, we replace it back into the same equation, sub back whatever they want us to sub. In this case, sub back the I to be 100, refine the L. So that's the general idea for part B, a 3 marks question. So in this case, we're going to sub L to be equals to 90 and I to be equals to 10 to the power negative 3 into the original L equation like this. So L to be 90 from the questions and I to be 10 to the power negative 3 from the question as well. So replace it into this original equation that we have. So 90 equals to 10 LG. I is 10 to the power negative 3 divided by I naught. So what we did here was replacing L to be 90 like this. So replacing L to be 90 like this. And replacing I to be 10 to the power minus 3, which is the one on top in green. So what we wanted to be doing is to find the I naught, which is the constants. So to find the constant, first thing first, we might want to divide by 10 throughout to give us a 9 on the left. And on the right side, we then therefore use the quotient law. Now take note that once we get rid of this constants, we are left with 1 times LG brackets, and there is a quotient, there is a divide here. Now what we're going to do is, this is the base of 10. Let's not forget LG is log to the base of 10, is the natural logarithm in this case. So I'm going to split a base of 10, a single log, into 2 logs base of 10. So therefore we're going to have it like this. LG 10 to the power negative 3 minus away LG I naught. So now notice you can see that LG 10 to the power minus 3 can actually be pressed in a calculator. So this is in fact now a number that can be used, that we can use the calculator to work it out. So now we can therefore make LG I naught the subject. So LG I naught is equivalent to LG 10 to the power negative 3 minus 9. Now, having said that, what we can be doing now is to solve for I naught in this case. Now, to be able to solve for I naught, what we do now is basically press this thing out in the calculator. So if we press this thing out in the calculator, this will actually give us a negative 12. Consider the fact that LG has a base of 10, so using the logarithmic form to exponential form equation again. So 10, base of 10, push the other side up, 10 to the power negative 12 equals to I naught. So let me just type it out. I naught is equals to 10 to the power of negative 12. So this is exactly what we need to replace inside. So this negative 12, alright, this negative 12 here, let me just change it to another color. This negative 12 here refers to this number that we have. Alright, if you press the calculator, this is a negative 12. So now we have I naught equals to 10 to the power negative 12. We can now replace back to the original equation because the constant has already been found. So you replace back to the original equations. L would therefore be equals to 10 LG brackets I divided by no longer I naught but 10 to the power negative 12 like this. So let's follow the questions. What happens now is that we're going to replace the intensity to be 100 like this. So sub the I to be 100, sub I to be 100 into this L equation that we have. So sub I to be 100 into this L equation that we have. Like this. So therefore, we should be having L equals to tens LG brackets 100 divided by tens to the power negative 12. Tens to the power negative 12. Like this. So this thing, in fact, we can actually work it out with our calculator like this. So what I do here is I just simply replace the top part here to be the one in green, which is the I to be 100. So working it out with a calculator, L should actually give us 140. Now to finish up this part B questions, we can therefore conclude that the loudness of a plane taking off is 140 decibels. And that's the answer for part B.